Is that not working? I think it's that one, maybe.
Yeah, no, this one's not doing anything.
No,
It's there. Try again. The light's flashing on here, but yeah. Wonder if I got anything popping up. Whoa. Never mind. My computer locked up.
There you go.
Okay.
Working. We'll get you up.
All right. We're good.
All right, so yeah, so really happy to have him here today. Can you guys please welcome him with a round of applause? Thanks, Neil.
Well, since you guys already clapped for me, I guess I can go home. Like, that's the point, right? So, thanks everyone for coming to the talk. Full disclosure, like I haven't drank Red Bull in years, so I'm literally shaking right now. I might go through the talk way faster than I need to. Just another reason I want to encourage like people asking questions during the talk, until obviously it becomes a blocker, then I'll just ignore you. So I put automation in quotes because as I talk about automation, people are saying like, oh, I didn't really think of that as automation, or like, I don't think that is automation. Well, I don't really care because I think it is. But I also want to say I sort of changed the talk. Apologies to the people who put this talk on. I promise it's not like a bait and switch thing. It's just I want to approach it a little differently. So I'm going to talk about the history of XSS at Twitter. And when you talk about history in Twitter, you have to mention the fail whale. Like, it's a rule. We get fired if we don't do it. I'm glad we don't see this guy as often. And then at the same time, we have to talk about how Barack Obama's account got hacked many, many years ago, which drew the attention of these wonderful people at the FTC who we dearly love. I actually think the contents of this is kind of interesting. It explains the boneheaded things we were doing, like a publicly accessible admin panel with passwords that are like equivalent to, donkey table. Just really not that good. But if you look at their suggestions, they're like equally as bad. But either way, we're under this order for the next 20 years. We have to have an effective information security program. Every time we mess up, that adds another 20 years. Or sorry, not adds, but starts over. So obviously 20 years in the world of computing is pretty unrealistic. But anyways. So we had to come up with philosophical guidelines to sort of guide what we do. This is sort of a recent thing. This wasn't in response to it, but it's been pretty helpful. These are not like groundbreaking things, but they're things that we definitely keep in mind with everything we do. Get the right information to the right people. That's two separate things in there. The right information, right people. Giving someone a PDF that comes out of any tool that anyone uses is just irresponsible in my opinion. Most of the people you're giving those reports, you can't understand them. And then also, you're probably giving it to way too many people that need to know, and they're just going to ignore it anyways. Find bugs as quickly as possible. Probably the most obvious one. Don't repeat your mistakes. If you keep making the same mistake over and over, like you have no one to blame but yourself. The best indicator of the next bug is the previous bug. Analyze from many angles. I think this is the one we take closest to heart. We don't use a single tool. We don't use a single service. We don't use a couple of services. We throw every single tool that makes sense to do so at each application. You can sit there and try to get like perfect use out of AppScan. You can spend days and days tweaking it to an application, or you can just throw a bunch of tools that are going to cover 80% of the case and hope through the overlap that you get close to 100%. Because no tool is perfect, period. Help people help themselves. We can't always be the police. People always want to do the right thing anyways, so provide mechanisms to let them do the right thing. Automate dumb work. If you're pushing a button, there's no reason you should be pushing that button. Keep it tailored. My girlfriend always hates when I show pictures of Taylor Swift because I have a very strong crush on her, but another very important thing, only use tools that make sense for you. Just for anyone not familiar with the concept of continuous delivery, first of all, I'm not an expert. It just happens that we're doing these things that falls under this category. But the way I at least summarize it is you want to be able to deploy by pushing a button. Everything should be automated, everything should be streamlined, everything should be nice. What does that mean? That means that anyone can push that button generally. That means that a deploy can happen out of schedule. But in reality, there is no schedule with continuous delivery. You might deploy 7 times in one day, you might deploy once a week. The thing is, there's no schedule. And what does that mean to traditional security waterfall methods? They don't work at all. Getting these people to at least come to you is a huge win. But if you're required to be there for every single deploy, you're going to be very, very unpopular, and you're going to bring the company to a grinding halt. And just another thing, like as companies grow, like every company I've been with and spoken to, they're generally understaffed. This is like a very generous graph, and it's completely made up because the InfoSec one is actually growing as the company is growing. Not as fast as it should, but you know, this is pretty much the best case scenario that I've seen. I just want to give you a little background on what makes up Twitter. This is sort of a very crudely drawn time graph of we were mostly Rails, and now we're getting to be more and more Scala, but we've got some Node apps, we've got a lot of JavaScript lying around, a lot of libraries, we've got some PHP, we've got some Drupal. There's a lot going on. So I wouldn't consider myself an expert in Python or PHP, but we use tools to make up for them. And this is sort of a summary of, or a combination of a bunch of the principles. Only buy tools, and only build, buy, or integrate tools that make sense. Like you need to ask these questions, like, is it useful? Probably an easy question to answer. Does it scale? That's the big one. Are the results easily digestible? Can they be consumed in some way? Again, a tool that gives me a PDF report will never use it. I need JSON, I need XML, just something. Can we 100% automate the use of the tool? Again, if you're giving me a PDF, I can't do that. And of course, that's how we keep things tailored. So the manual security workflow is traditionally like this. You run a tool, you go to Reddit, it comes back, you look at the reports, you sort of maybe manually do things, you fix stuff, but then you're just going to repeat this cycle over and over. There was already a few manual steps in there. So instead, use these automated techniques, put your robots to work, and I'll get into sort of all the things that this does, but again, we're not pushing any buttons. So I want to talk about Brakeman. Brakeman is a static analysis tool for Rails. It works. You can see a quite dramatic drop-off as soon as we started using it. So, is it useful? Yes. Does it scale? Absolutely. Find me a static analysis tool that runs on something with, you know, millions of lines of code that comes back in about a minute. You're not going to find too many. If there are more out there, please let me know because I would like to use those tools. And then on the twitter.com code base, which was sort of at one point the largest Rails code base in the world, it takes about 2.5 minutes. Now, when can you run Brakeman? After you deploy the code? Probably a bad idea. QA? A little more common. During code review process? Maybe. CI? Hopefully. Oh, I'm looking at the wrong screen. When you commit your code, that would be really good. When you run your tests, that would be really good. Most people at least make sure their tests pass before they push to production. But ideally, you'd want to do this when you're saving your code.
How good are the breakpoint results for Rails? I mean, what level of false positives do you get out of it in general?
For the Twitter applications, we have absolutely 0 false positives. Part of the reason behind that is because we somewhat own the tool, and every time we see a false positive, we treat it as a bug that has to get fixed. Because we're doing this sort of in a purely automated fashion, a false positive is just going to make this whole process 10 times more cumbersome.
Err on the side of using the tool where you don't mind if you have a false negative, you just more concerned about false positives, or you could dial
we do a lot of regression testing, so if by fixing a false positive we cover up a previous finding, then like that's a worse bug. We definitely would say that a false negative is a higher priority than a false positive, but false negatives are a lot harder to find. You know, as I'm reviewing code, I go, Brakeman should have caught this. That's another bug that we file. And this is finding bugs as quickly as possible. There are some tools that run static analysis even before you hit save, but I guess that's faster. So this is the traditional graph that shows the continuous delivery cycle. So as you can see, it's all about getting in as soon as possible, running those tests, and then also if you look at the individual lines, they say trigger, trigger. There's only one manual process in this entire thing, and that's the check-in. So how do we apply Brakeman at Twitter? All right. First, watching the master branch. This is usually after things go to production. Not good. Deploy scripts. This is a big win for us. You know, basically before they deploy the code, we make sure that no new vulnerabilities have been introduced. The little kickback thing was quite nice because we had a lot of confidence with this. And then we thought, what about if we just, you know, enforce it on the code review? Every time someone submits a branch for review, the tool automatically runs. False. Like this, we got a lot of pushback from this. This is too invasive. Even if a tool only takes 20 seconds to run, requiring it on every run, which will essentially triple the amount of time it's going to take to submit that review, didn't make us very popular. This is not in use today. And then we came up with the Security Automation Dashboard, also known as SADB. This is, I'll do sort of a condensed version of what SADB is, only focusing like on the Rails part of it. But this is where the security team, the management, anyone can go to see like the status quo of security across Twitter, to exaggerate it grossly. So what does SADB do? You know, going back to that graph that we saw before, the developer will push code, and then our Mesos job, which is like a private cloud task management service thing, will pull the code, run Brakeman, send the results to SADB, just raw results, JSON, and SADB actually makes the decision. Like, is this a new vulnerability? Was it there before? Who wrote it? Who should be notified? And then we send them a very detailed report. And this is getting the right information to the right people. What does SADB look like? This is just, again, the portion of Brakeman. You can look at the individual results. You know, what is it? When was it introduced? The code location. This is just like a link to our private GitHub, whatever, private Git server. Take you to the actual line for the branch, the exact line of code that introduced it, even if the code's not in master. And then we look at the code as it was seen by Brakeman. Brakeman does a lot of, I don't know what the right term for it is, but it'll inline everything. So when you look at the result of a template that shows XSS, you can see how that XSS got there. Oh, it came from a request parameter called XSS me. It's pretty helpful. And we provide documentation on how to fix each individual thing. We're talking about taking this a step further and actually like taking your code and generating like a suggested fix for it if it's like a one-line thing. We're kind of like, that could go bad too. If we start giving people wrong code snippets to copy and paste into their document, probably not good. And for the super attentive, you notice this bullshit button on the right. It does say bullshit. This is the way that we let developers tell us, hey, your tool's wrong. If you don't provide that feedback cycle, then they're just going to think that we're this heavy-handed organization just slapping security around. So this is just sort of a screen cap of the whole SADB process. Like, I actually like that the screen is huge because you can actually see it, hopefully, maybe. Usually it's like little tiny ones. Anyways, so this is me. I'm going to create a new branch. And then I'm going to edit it. And I'm going to, oh, you can't see this. I'm going to insert an open redirect. Just trust me that it is an open redirect. I push the code. And if you look in the top right, I got an email. SADB sent me something. I introduced a vulnerability. That's not cool. Go back to here, see some information about it. Go to that detail page we saw earlier. Okay, that's my vulnerable code. That's how Brakeman saw it. What do I do? Oh, no, 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 no. Oh, hey, that last one looks cool. That's probably what I'm supposed to do. Go back in, make the change. And this is where the video actually lies. Like, we don't have this next feature coming up anymore because it was not very useful. But I fixed the vulnerability, I pushed the code, and now I get an email from Sadby saying that everything's cool. Now you can take that a little step further and use what's called guard Brakeman, which has like 0 traction. I'm still kind of confused why. But it's basically a tool that every time you hit save, it'll reanalyze your code and alert you for new, fixed, etc. So in this case, I'm introducing XSS, hit save, bam, Brakeman tells me that's not cool. I fix it, done. That sort of instant feedback cycle is very useful, at least for me. Oh, and then I go on to fix like 3 more. It's not really useful. Another tool, sort of to shift off the Brakeman line, is a tool called Phantom Gang. Phantom Gang is a node process which spins up a shit ton of Phantom.js instances, which is a headless WebKit browser. You are seeing the activity of the website as the user would actually see it. This is not grepping through the HTML. Actually, in some cases it is, but that's not important. Then Phantom Gang will post the results back to Sadby, and then from Sadby we can generate Jira tickets. Like full disclosure, this hasn't been too useful for us. It's not a traditional scanner that's looking for XSS or SQL injection. It's looking for things that those traditional scanners don't look for, because we do use traditional scanners too. This will look for things like mixed content, forms posting to HTTP, anything like that. Wasn't really useful, but, sorry. So then we started thinking about, static analysis for JavaScript. Since it works so well for Ruby, maybe we can leverage that. Oh, I should have mentioned, Kyle was saying something like, he's not a Rubyist, he's not a hipster. I'm a Rubyist, I'm a JavaScript guy, I'm a Node guy, and I'm a Scala guy, but I hate hipsters. Anyways, jQuery is a sink. If you put user input into that constructor, you are vulnerable. Don't do it. This is something that's easy to find with static analysis. And sort of, I want to sort of talk about how the scope for static analysis is so much, scope for static analysis for JavaScript is so much smaller than everything else. You're only looking for one vulnerability, really. You're only looking for those sinks and tracing them back. So, in an effort to make Phantom Gang actually useful, we thought, we can hook up the JavaScript static analysis to Phantom Gang, which is essentially just a crawler at this point. We can suck down all the JavaScript on the page, suck down all the assets, and then analyze those sort of at that point in time when the user visited the page. What were the possibilities for DOM-based XSS? And we called it Coffee Break, just because it was like Java, coffee, whatever. It's no secret, I think, that Twitter has sort of reinvented itself a few times. I think this process of reinventing yourself is incredibly useful. You can carry forward all the knowledge you learned in the previous implementation to the new one. This little random logo here was like the only thing I could find for Mustache, which is a templating language that we used. And sort of over these 3 first iterations, settling on Mustache, I think, was a huge win in itself. Mustache doesn't allow these complicated templates that allow you to insert arbitrary code into it that generates, what the hell? It's very limiting in the fact that you can only insert values, you can only have conditionals, you can iterate over a list, but in reality, you're writing HTML code and putting in placeholders for the values. This limitation makes security very easy because you can just search for any time. Sorry, back up a second. For inserting a value into a page, you have 2 options: the double stash, which is escaping it, or the triple stash, which shows it unescaped. So how do you find all the XSS in your app? Search for triple stash. It's that easy. And then just a little more background, some of the frameworks that some of the upcoming content is built on, is we have this concept of the owner's files, such that if any of these things change, you're automatically added to the review. You could see uses for this, putting it in your authentication system, or anything that's super highly critical. Let the security team know every time someone tries to change it. And again, this is making sure we know about it before it happens. Another feature is what we call the decider. I think a lot of people are doing this at this point. You know, it's a kill switch. It allows you to turn off a feature at any point or turn it on, or it allows you to dog food things for your employees only, you know, or you can let it roll things out slowly. I think this is becoming like a very common trend in IT, especially like rolling features out slowly to percentages of your users. But in the security world, it means that we can just shut off things when we need to. So we sort of thought about making security opt-out. Like, can we take some of these decisions out of the hands of the developers, or at least like give them the right tools to do so? And going back to our whole rebirth, you know, there was the Rails, there was the Phoenix, pre-Phoenix, T1, but the big gain was when we moved to Scala. And we have a framework called Macaw Swift. That's 3 Taylor Swift images so far, if anyone's counting. Macaw Swift, again, it's a Scala-based framework for building web applications. Again, the super, like, people who are paying attention would notice that Swift occurs in both of these things. We're able to reuse the same templates for our Ruby and Scala backend, which is incredibly useful. But it really made us think about like ubiquitous security, like making sure security is everywhere. This involves pushing security up and as far down the chain as you can. You know, what am I talking about? I'm talking about setting headers in your reverse proxy. Yeah, your application can set response headers, but if your reverse proxy can, then you can make sure you have full coverage. Again, like carry forward everything you've learned to your new framework. So our Scala framework took a lot of things from Ruby on Rails, like pretty solid CSRF protection. We built that right into our new framework. And if, you know, providing changes to the framework is too invasive or not really possible, always provide your libraries to do the exact same thing. And this is, again, helping people help themselves. So going back to the whole double stash, triple stash thing, double stash, yes, triple stash, no, always bad. But it still happens, and things still sneak through, and people still think they need to do this when they don't really need to. So we thought about programmatically enforcing the use of these triple stashes. So if you want unescaped output, you want triple stash, you want to introduce XSS, that's cool. You need to add the line, the file and line number to this special file, special YAML file that security is an owner of. So what happens, introduce a unapproved triple stash? Well, in development, it'll just throw an exception, and in production, it'll just render absolutely nothing. We modified Mustache in this way to always verify that the triple stash was allowed. And I already said that. Same thing goes for CSRF. It's opt-out at this point. You really don't want your CSRF protection? Cool. Put it in that YAML file that we watch, that we have to approve. Oh, I should say also, it doesn't just add you to review. The owner's concept doesn't add you to the review only. It actually makes it so nobody can merge the code until they've gotten approval from someone in that group. So at this point, it's pretty hard to get a triple stash into production. And same thing goes for redirects. That was a big problem of ours before. We modified the Rails framework so that anytime you want to redirect off-site, again, it'll either throw an exception or just not do anything unless you've sort of whitelisted it. Oh, and that's another thing we put behind the decider feature, is just straight up not doing any redirect whatsoever. And these were all the mistakes we made back in Rails land that we didn't want to carry forward. So now I want to talk about something that might be a little controversial. That's sort of going against at least OWASP's recommendation, contextual escaping. If your framework only provides one method of escaping, then how do we deal with all this contextual escaping, putting you know, valid values into a script context or CSS context? Well, you just don't allow that. You don't allow people to do that. You're going to get XSS if you do that. So we've made it a strong, firm standing that we are not going to get involved in contextual escaping. We're just not going to do the things that lead to the need to do that. Does that make sense? But what about static analysis for Scala? We don't have any. And to be honest, it's probably pretty low priority at this point. We looked at a few vendor tools, and we looked at a few vendor services, and we didn't really think anyone could really handle it too much or too well. And like I said, we haven't gone into the world of developing it ourselves because with all these programmatic enforcement of controls, it's kind of hard to introduce a vulnerability. I'm not saying it's impossible, but it's certainly hard. So I don't even know if we'll ever do this. We might. So now this is sort of a context switch. This is what I was talking about when people don't agree on the word automation. Applying these 5 headers automatically makes your application more secure. That's automation. I don't want to go too much into this because there's a talk tomorrow that talks about the browser features that are for security, and I imagine there's going to be a lot of overlap here. I do want to talk about one thing though. I promise headers aren't boring. They're a very interesting topic. And a lot of people think like, oh, well, if these headers are doing the work for me, then why do I have to write secure code? Blah, 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 defense in depth, don't rely on one control, etc. But I think we're actually at a very unique time right now in that a lot of people agree that it's good to apply these things. For example, one that I'm not going to talk about, HSTS, which ensures that the communication is all over SSL. Well, your ops guys are going to like that because it's less load on the server. Your product guys are going to like that because there's no round-trip redirect. So it's a good time to sort of push for these headers in your organization. I want to talk about content security policy specifically. This has sort of been my life for the past, 6 months, and probably will continue to be my life for another 6 months. I have very strong opinions about this too, and I talk about it a lot on my Twitter account, so much so that I had to create a separate account so all my CSP babblings could be there, instead of just constantly flooding my followers, which I'm still amazed I have any. So I'm going to say that content security policy is reshaping the security model. I'm also going to say, oh no. Anyways, it is a very complicated spec. There's no doubt this is the most complicated header I've ever seen. There used to be great differences across browsers, but with the recent Firefox release, which is still in beta, they support the standard format. It's not widely adopted. I think Veracode did their study and found that only like 50 out of 1,000 sites applied content security policy. I did my own little study of the sites that did it and found that more than half of them weren't even valid headers anyways. So just further reiterate that point. Again, however, it completely eliminates reflected, stored, and DOM XSS. Another very bold statement. It ensures that you never load mixed content. It allows you to accept arbitrary HTML code from users, which is like the #1 thing you should never do. I'll explain how all this works in a little bit. And it actually even finds bugs in your code. We had a couple times where reports from CSP were coming in going, man, it's trying to connect to host undefined. What could that possibly be? JavaScript error. So is there anything CSP can't do? This is an example of CSP in action. Oh, I have an inline script tag. It says like, if this console log actually happens, then there's potentially cross-site scripting on my page. And you can see it did. So I'm going to go back and use CSP to disable inline JavaScript. And then I go back and I refresh, and it says it refused to violate it. If your CSP policy does not allow things to happen, a violation is triggered. The violation can either just send a report or can actually stop the action. So how would the browser know? How does it know whether a script of Java or a block of JavaScript was inserted by the application as expected, or if it was inserted by a hacker? There's no way for the browser to tell. This is like server-side knowledge. So, what is inline JavaScript? This is all the examples. You can have on-click events. You can have JavaScript JavaScript URIs. Inline script is the most basic example. But it also applies to eval. You can also restrict the use of eval, which is calling eval or calling set timeout or making a new function with a string object. The same thing goes for inline styles. These are the examples of inline styles. And to go back to that example I said of what never to do, don't ever do this. Don't ever put, first of all, I'm going to be very dramatic. A lot of the statements I have, people have trolled me on later of me being like a little too hardcore about this, but I don't care. So that's the first one's an example of people putting dynamic data into a script context. Same for the next two. And the last line is inline styles. Code does not equal data. Do not do those things. This is a very purist way to think about it, and I won't back down from this. People were saying this has been impossible. It's just not really feasible, but I don't think so. And of course, remember that every time you write inline JavaScript, God kills a kitten. And this image specifically has gotten me trolled quite a bit. We stand behind CSP so much that it's now part of our NHO. In the NHO, we say, never write inline JavaScript, never write inline styles, because we're going to apply a CSP policy that will not allow that. CSP policy is kind of redundant, but whatever. But CSP is not trivial. CSP is hard. But CSP is also awesome. There's websites that help you write your own CSP headers. There's extensions that will learn what your CSP policy should be. Or if you're like super paranoid, you can build your own policies for websites. It should also provide libraries to help apply CSP. It's this big, long, giant string. Of course, you could always manage that, but being able to break it down into chunks makes things a lot easier. That's why we wrote the secure headers gem. I get trolled a lot because it's the worst name for a product ever. But it does this. It'll allow you to supply basically a YAML configuration, and that it generates the CSP policy. And this is browser aware, so it applies the right header for the right browser, or it might not apply any header. But you don't have to care. This is automatically done. Helmet is for Node, and I was talking with the creator of Helmet, and he's going to add the same browser detection, conditional application stuff into Helmet. Headlines was just released not too long ago. It doesn't sort of have those smarts, but it does have the concept of a config file that dictates what your headers will be. And then we ported secure headers to Scala. This is coming out soon, hopefully. It's in review right now. And during a hack week, I wrote this little tool. We haven't actually integrated into anything yet, but it was incredibly useful for at least me. I hope to make it useful for other people. It's basically just a node server that will accept requests, but it also contains a lot of helper libraries that you can use on the front end as well. The libraries will tell you, is this header valid from the first place? It'll actually validate the grammar of your policy. What does this header mean? What is it doing? Given a header policy, it'll say like, oh, you're allowing inline JavaScript. You're allowing, you can load an image over any HTTP host. Things that you might not realize you've said. And of course, I just want to get this thing out already. It'll also explain what a CSP report that's coming in probably means. This is a little difficult. This is probably the most changing part of CSP. I stand by, this is also something that a lot of people disagree with me on. I still think that applying the right header is worth it. People have said there's a lot of bugs with like the older implementations, and the Firefox one is really confusing. But no disrespect to anyone that says that, I think they were doing it right. First of all, for Firefox 23 and above and Chrome 25 and above, you can supply the standard header name and the standard header format that's all in the spec. This is good. But Firefox before version 23, you had to supply the custom or the original implementation done by Firefox. For Chrome less than 25 and Safari 6, you send the standard header but with a different header name. And for IE, Safari less than 6, blah, 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 you don't supply a header at all. Specifically, don't supply a header for Safari 5, because if you do, no matter what the contents of that header, whether you're in block or report-only mode, you're going to get a blank white page. And this is true for mobile, desktop, probably not what you want. So here's all the rules you need to implement the right header for the right user agent, and this logic, like I said, is in 3 of the 4 libraries that I talked about. And what does this madness look like? I counted 6 differences between these 2 headers. The top one is sort of the original Chrome one. The bottom one is the Firefox one. There's probably more than 6. I didn't really try very hard. But this madness is just madness. And we needed to adopt the standard, and I'm really glad we did. And I want to sort of get on a soapbox for a second and talk about a feature of CSP 1.1 that I feel very strongly about as well. There's a concept of a script nonce or a script hash. This is for what about when you can't remove the inline JavaScript? There are actually real use cases other than just performance where you cannot remove the inline JavaScript. Or maybe you just have a legacy application with, oh my god, amount of JavaScript. You can actually apply these two techniques to whitelist specific inline blocks. The nonce, as most of you probably know what a nonce is, you just apply a random value into the header and you apply an attribute to the script tag. I think that's the absolute wrong way to approach it because, I mean, all I need to say really is you break caching. With that unique value per user, you cannot cache the contents of that block. Hashing, on the other hand, I think has a lot of benefits. You basically just hash the canonicalized data that's inside your script block, and then you put that hash value in your header. We're not introducing a new attribute. These values can be computed on deploy time. There's just really a lot of benefits. If anyone wants to talk to me more about this so I can get more people like on my side, that'd be great. As I sort of alluded to before, CSP has a report-only mode. This means it won't affect your website, but you'll still be able to collect the reports that it generates. There's very valuable information in these reports. The document URI, where did this violation occur? The violated directive, what happened? The affected directive, what actually happened? So in this report, it was a case of a localhost 3000 home was trying to connect to a internal instance of live reload, but it was not allowed by the CSP policy. Probably should have been, but just an example of a report. What else does these report tell you? And I put anonymously in there because we strip out any identifying information from these reports. Generally, the cookies get sent along with it, which means you can trace it back to the user. We don't want any of that garbage. We want to evaluate this in a very anonymous fashion. Privacy is kind of a big thing in CSP. Personally, I think that you should have to opt into even sending these reports in the first place, because I don't want to send them by default. But we take this very seriously. What did I tell you? A lot of nonsense. Probably half the reports we get, we just kind of throw away because there's not enough information to make it useful, or it just indicates that this is a browser plugin that's just not compatible with CSP. Unfortunately, this is not completely fixed yet, but it is getting better. I'm sure the GitHub guys will tell you about how CSP broke their bookmarklets and all their plugins, and it's not a good thing. Detecting mixed content, really easy. If your document URI is HTTPS whatever, and the blocked URI is HTTP, mixed content, bad. Unauthorized resource load, like let's say your application gets hosed and all of a sudden it's serving up a bunch of porn pictures from Russia or something. You would be able to tell from CSP because you did not authorize that host to serve it. How many users have LastPass installed? LastPass is just not compatible with the strict CSP policy and is probably the source of maybe half of our violations. And this was an interesting one too. We found a lot of people CNAMing our content. So these random websites in Russia that go to twitter.com and get all of our headers, which clearly are violating almost all of them because we're now on a random host. People have asked me specifically to put in tips on like analyzing these reports. One thing I would say is like focus on one site or one domain at a time. Focus on one violation point or violation type at a time. You know, like if you've got 10 times more style source violations than image source, you probably want to look at where all those style source ones are coming from. Look for patterns in the results. It's pretty easy to identify systematic bugs or issues, going back to the root cause of it. It's sort of good to just sort of classify these things into categories, set up like some kind of safe search so you can already sort of get the lay of the land whenever you can. Filter out the noise if you can. LastPass is an easy one to filter out, especially on Firefox. I should have said that Firefox sends a script sample if you violate inline JavaScript. It'll actually send you like the first n bytes of the JavaScript that tried to execute. So if you search by LastPass, you can immediately get rid of those. Or what's commonly the more approach, you just dork around until you find something. I wouldn't say that my CSP diving is organized in any way. But clearly this is something that you should monitor and tune over time. We posted or we made a blog post recently about CSP, and these values were unhidden or unblurred out. Not really much use in protecting that. And then, of course, you get the big data aspect of it to analyze these reports. No, it's not a very good example, whatever. And of course, more and more ways to visualize it. If you take away that big pink one, which is no longer there today, things get a lot nicer. And this sort of, you can group on what's going on. This is, I was grouping on the script sample. And if anyone recognizes that top one, which is Google Analytics, which is like generally the biggest violator of inline script restrictions when you first start, because Google Analytics is on every page, and they just tell you to copy and paste it right into a site-wide thing. It's really easy to fix, and by doing so, you're going to reduce the number of reports you get by like 11-fold at least. We got to have a way to monitor our progress. We built up this stupid, simple page that goes out and curls all these hosts, sort of sees what the headers are coming back. Another good place for people just to go look at the status quo of things. And then we do sort of a little more smarts, I guess you would call it. If you see ads.twitter.com, like the smiley face is yellow. Sorry, this whole thing blocks it, but let's see. This is content security policy report only mode. This is content security policy enforce mode. I forget what the first one is. Probably HSTS. So if you go over each one of these, it'll explain why it's yellow. It's because it allows inline JavaScript. We consider it yellow because you shouldn't allow inline JavaScript. But retrofitting applications is not always trivial. So we give people some time. And we help them. We remove the inline script for them when we can. So, like, I would have sold you on the other headers, but if I just sold you on CSP, hopefully, like, I don't see any reason not to use it. It's very powerful. The support of it is becoming pretty ubiquitous. And if you go back to my dramatic statements, you can get rid of XSS for good. So sort of other random-ish areas that didn't really fall into a category of things. Going back to that FTC order, we are required to review any code that affects public APIs. We used to have this little janky script you'd run at the end of the month, and you see, oh man, we missed all this crap. Obviously not good. So now we have a page we just go to, and it's like, oh, this thing needs to be reviewed. We actually have a cron job that goes like every 4 hours or so that checks to see like, oh, someone actually submitted code that security hasn't reviewed yet. We need to get on that like right away. And again, this is just like running a manual script at the end of the month, no good, no good. And again, just more random things that we're doing that might be useful for other people, maybe not. Oh, so we have Threat Deck, Web 3.0, Cyber Intelligence Cloud. I just threw a bunch of terms in there that I could. All it is a TweetDeck setup with like 8 different columns that are looking for things that might indicate that Twitter's in trouble. Shady Spots just looks for the use of dangerous functions. This is not static analysis, this is grep. So it'll look for things like .inner HTML and things like that. Not a good enough tool to automate the use of because the results are so noisy. Just because you used a dangerous function doesn't mean you used it in a dangerous way. Another thing we call header alerter, dude. Every time a new header gets added to a page or removed, we're notified. Like if someone tries to get rid of CSP, we'll know. And GSC, which I forget what it even stands for, is a tool used to search Git repositories for passwords. This is mostly useful for when we open source things and people like leave their database passwords in history somewhere. We actually, instead of this now, we just squash all the commits into one thing before we open source. But it's also useful if you're reviewing code. We take the policy that passwords should not be any application code, and this makes it easy to find them. So with that, I just want to sort of leave a dump list of Twitter accounts like I think people should follow, at least if they're interested in things like Breakman and CSP, SADB. I'm the person behind all these alternate personalities except for Twitter security. But then I definitely, in terms of CSP, follow Adam Barth, Brad Hill, and Ian Melvin. They are definitely some of the best movers and shakers in the CSP world. And with that, are there any questions? We want it to be, but it's so low priority that we might not really get around to it. Luckily, there is a commercial product that provides the exact same functionality. I don't want to promote it, but I can certainly tell people about it offline. I don't see a reason why we couldn't open source it. But at the same time, it's a pretty dead simple thing. It's just a Git hook, basically. Well, I mean, I can't say that everything we do is good for everyone. But I think if you at least start out with that mentality or you adopt that mentality at any point, eventually you can get to the point where you're not using contextual escaping. Pretty much. There's a few cases where you have to take the stance of code not equaling data, and instead of like plopping a value into a JavaScript variable, add as an attribute to a hidden div somewhere, and then just read that value with JavaScript. If you have a complex object like a hash or what JavaScript calls them, like associative arrays, maps, whatever you want to call them, sometimes you need to get like 15 configuration values onto a page. The way we do that is we put inside a script tag of application JSON, of type application JSON. So it doesn't execute, even if you try. We HTML encode that. Again, it won't execute that because it's a bunch of garbage. But then if you read the contents of that script tag and then parse the JSON, now you've populated a JavaScript object with all the complex settings, instead of calling var x equals something to JSON. Or an on-click event, or anything.
But they would require JavaScript encoding, is that what this says?
Yep.
Oh, okay, so you get away with this because you don't do certain things that require contextual output encoding.
Exactly. And part of the NHO, don't put dynamic data in script or style context ever.
Last question. I'll buy you here tonight. I want to hear more. How do your developers accept this?
Absolutely. Going back to the time of convergence thing, we have enough purists that say that JavaScript does not belong in your HTML files. So we didn't even have to focus on them. We just sent out a company-wide email. Everyone loves company-wide emails. And the title was Moratorium on Inline JavaScript. We got like 2 people saying, oh man, and 150 people saying, thank God. I don't know if that's common against every other organization, but it definitely was. And it was definitely a huge win. We only use one type of encoding, HTML entity encoding. It's in every single framework ever, hopefully, by now. Maybe. Maybe not. Anyone else? I'll be outside, some chat to me. I'll tell you the company I was talking about, whatever. Thanks.